new content. Excel stores dates and times as a number representing the number of days that have passed since midnight on the morning of January 1st, 1970. So if I type, for example, today is November 5th, that should have been easier to remember. You would have thought anyway. 11:05:19, and it's currently 11:04 a.m. So this right now is being presented to us as a date and time, but the way that it's actually stored is as 43,774.46111111. That represents 43,774 days have passed plus 0.461111 of a day. So if you take 0.46111111 multiply it by 24, you probably get about 11 and a 12th hours. Does that logic make sense? So that's what's happening behind the scenes when Excel is keeping track of a date and a time. If you want to switch it to a date and time, you can switch between the different formatting options. So for example, you could format it as a date. You could format it as a long date with like words and stuff. You could present just the time information. If you wanted more options, you can actually go into format cells and you can change from 12-hour time to 24-hour time if you want seconds or don't want seconds. This interface here is useful when you are creating graphs. If you're graphing something over time, sometimes having all of the date and time information is a little bit superfluous for what you actually want to do. In most of those cases, like for example, if we started at midnight, let's go with 12:01 a.m. and then plotted a whole bunch of information throughout the rest of the day for today. Let's go with random number between 2 and 5. This is what we are plotting here on this 5th of November. It doesn't have anything to do with gunpowder, treason, or plot. If I wanted to create this plot with the date and time information on the bottom left, I could do something like this. If I wanted just date and time, I can switch between the way that this number is formatted, and I can also change the way it's presented. So for example, if you wanted the graph to start at midnight, you don't start at 43,773.8, you start at 43,774 on the nose. And if you wanted it to end at midnight, you could stop at 43,775. If you wanted there to be a big break every 6 hours, you could say 0.25 as the major demarcation. A quarter of a day would be 6 hours. If you wanted every 3 hours, you could change it to 0.125, etc. If you wanted this to be a little hash mark every hour, we could figure out what 1 divided by 24 is. Hey, you guys are engineering students. There's what, got to be like 50 calculators in this room? What's 1 divided by 24? Thank you. 1 divided by 24? 0.025 if I add in hash marks. Something like this. Now I've got a nice little line every hour. If I want to change it from showmatting, 12 o'clock a.m. to something different, I can change the way it's presented like this. I could say 0, 1, I could say 13, I could say seconds or without seconds. If I wanted PM or AM, if I wanted to just add a whole bunch of information so it's impossible to read, I can do that this way. Does that logic make sense? Yeah, I would prefer something probably more like this. If we want a date and time, we can switch it to date. That is plenty of information shown on the x-axis. Much more readable now. Other questions on the subject of formatting? Okay, well, my logic today is we have talked a lot about new functions and new ways of formatting data, and it has been a little bit of a fire hose for people who have not used Excel much before. So what I want to do today is not really introduce any new functions, maybe the odd row function that we talked about very briefly last week, and just work through an example problem. I want to try to describe the way that you could approach a problem in Excel, and because you guys are supposed to have taken pre-calc, most of you are somewhere in the neighborhood of Calc 1 at the moment. So let's work through an introductory calc example. Freeman sums. Oh no, indeed. So if you were to imagine a plot of x versus y, and I was plotting a line of y is equal to 3x squared, I would get something like this. You'll notice that's beautifully symmetrical. Such is the nature of my artistic talent. If I asked you for the integral between 0 and 2, referring to this region under the curve between 0 and 2, what is the integral of 3x squared from 0 to 2? 8, correct. Take the integral, power rule would produce 3 over 3 x cubed plus the constant that we're ignoring, plugging in a value at 2, 2 cubed, 8, subtracting a value of 0, 0 cubed is 0, 8 minus 0 is 8. But let's say we didn't know that. Let's say that we wanted to try to come up with a representation of the area by breaking it into rectangles. So if we were to break it into, say, 4 rectangles, wherein we had a break at 0.5, a break at 1, a break at 1.5, depending on how we define our rectangle, we will get either a left-hand side Riemann sum, a right-hand side Riemann sum, a trapezoid method, and the more breaks I have, the better my representation of the area under the curve is. Integrating is all well and good, but understanding the ways behind it is also useful. If we were to do this in thermodynamics, for example, we'd be figuring out how much work is occurring by looking at a graph of pressure versus volume. If we were looking at this in fluid mechanics, we'd be figuring out how much volume is flowing through a certain amount of area by considering its velocity in the cross-sectional area. But for now, it's arbitrary, 3x squared. If we used a left-hand rule, our rectangles look like this. We have a rectangle with 0 area. We have a rectangle with this amount of area. We have a rectangle with this amount of area and with this amount of area. So let's imagine, for this weird example, that we were trying to build a calculator in Excel that would do this for us. How might you approach that? Depends a little bit on the granularity that you're looking for, right? If you want just to be able to solve 3x squared from 0 to 2 all the time, you just have an Excel workbook that outputs 8. But if we wanted to be a little bit more versatile, be able to handle different polynomials, maybe something with a cube in there, maybe a cube and a second and a first power plus a constant. We wanted to be able to change how many steps we had. We wanted to change the minimum and maximum bounds. We could set up an Excel worksheet for that. Again, this isn't necessarily because you have to do Riemann sums all the time in your life as an engineer. This is an example for which you have context already. This premise is useful in a lot of circumstances. Excel is basically like the screwdriver of your toolbox. There are specialized tools that are more useful in different circumstances. But dang it, if you don't always have a screwdriver somewhere nearby. Excel is on effectively every computer you're ever going to use. And yes, there are specialized software packages that solve special things. But Excel is the thing that is constant. It is there with you always. It's never going to give you up. It's never going to let you down. It would never run around nor desert you. I'm going to approach this by creating a table, something like this. And in my table, I'm going to set up a framework for my calculation. So this table that I'm creating is going to have more information than we actually need because I want Excel to be able to use as much of the table as it needs. So in my first column, I'm going to have x values. In my next column, I'm going to have y values. In my next column, I'm going to have probably the width of the rectangle. That's going to be important. Let's go with delta x. And then in my fourth column, I'm going to have the height of the rectangle. And since we're comparing and contrasting using a computer to do all our math anyway, let's have it calculate what the area would be of a left-hand Riemann sum, of a right-hand Riemann sum, and using the trapezoidal method. So I don't want to write left-hand Riemann sum. I don't even know if I can spell Riemann sum, so I'm just going to type left-hand Riemann sum. And then in my next column, right-hand Riemann sum. And then trap. Go full Akbar and define that column as a trap. question so far. Okay. Now this table is going to be automatically populated by Excel. I want to give it enough of a framework that it can populate however many cells we need. So for example, even though we only have 4 rectangles here, if I built the table to be able to accommodate like 8 rectangles, then if I were to change the number of breaks in my Riemann sum from 4 to 5, Excel can expand how many cells it's using. Or if I were to make it so that it could accommodate 15 rectangles, I have even more options available to us. So what do you think is a reasonable number of rows to add here? I agree. Let's go with like 10,000, shall we? So I'm just going to navigate on down to row number 10,000. I'm doing this by holding down on page down, by the way. If you scroll, it takes forever. You can also, as a side note, if you just highlight the entire column, you will highlight all of the cells that Excel has allocated to that column. And depending on if you have 32-bit or 64-bit operating system and therefore Excel installation, you can have hundreds and hundreds of millions of cells. But let's not overload the memory on this potato up here in the front. Let's stick with a reasonable 10,000, and specifically 10,001. That way Excel has 10,000 spaces, which it can accommodate however many rectangles we need, as long as it's less than 10,000. Okay? So I'm going to format this as a table. I'm going to tell it it has headers. And I'm going to rename it. Okay, here we go. R-E-I-M-A-N? N? N? N. N. Okay, Riemann is my table. Same page so far. That'll be easier. That way we definitely know that we have too many n's. We don't know exactly how many extra n's we have. We just know that it's excessive. And that's really the important part, having certainty in the fact that it's wrong. Now I'm going to come up with a function over here. I'm going to say the constants for an equation. And let's just build this calculator to be able to accommodate any 4th order polynomial. Actually, I need 5 cells for that. So this is going to be anything that follows the form y is equal to a x to the 4th plus b x to the 3rd plus c x to the squared plus d x to the 1st plus e x to the 0th. And I'm going to give it values for a, b, c, d, and e here. So these 5 cells are what I actually want the user to be able to input. And to denote that, I'm going to use yellow, the time-honored tradition of this is a user inputable cell. Okay, next, I want the user to input where to start. So the left-hand side of the area that I'm considering, let's go with the minimum value. The right-hand side of the area to consider, let's go with the maximum value. And let's go with number of steps. So this will be yellow, this will be yellow, this will be yellow. So what I'm doing in that equation right there is 3x squared. So I want c to be 3 and everything else to be 0. Furthermore, I want my minimum value to start at 0, end at 2, and to take 4 steps. Then, let's calculate the area using left-hand Riemann sum, the area using right-hand Riemann sum, and the area using the trapezoidal method. Nope, that's not what I want. Let's merge together these cells. Beautiful, beautiful, and beautiful. Okay. So what I'm going to be outputting are values in these 3 cells. That'll be the actual output of my calculator. Okay, so to review, these are where I'm inputting parameters. The calculator will perform the number of steps it needs to take in order to calculate all those rectangles individually. It will sum them together and present the answer here. That is what we're building. Okay. So what I actually want to have happen automatically is I want there to be a value at 0, 0.5, 1, and 1.5, and 2 for the first 5 rows of the x column. Now, how could I write a function that returned 0, 0.5, 1, 1.5, and 2 based on this information, and every cell after that, I want it to be blank? I'll give you a minute to wrap your brain around that. Let's start by deploying a row function. So the row function is going to be the current row that we are in. So when we're in row 2, this function outputs 2. When we're in row 8, this function outputs 8. If I were to take row minus 2 and then make a typo and then correct the typo, now I get 0, 1, 2, 3, 4, etc. This is essentially an index of where I am in the table. Now what? We can. We could say something like, well, if I were to take the maximum value over here in cell I6, make that an absolute reference, subtract the value in cell I5, make that an absolute reference, and then multiply that by row minus 2, that in and of itself is not going to give us what we want. So what do we have to add to this calculation to make it give us 0, 0.5, 1, 1.5, and 2? Okay, check this out. What if I divide by the number of steps? So now I'm taking 2 minus 0 divided by 4. That equals 0.5, and I'm multiplying that by the quantity row minus 2. So that'll give me 0, 0.5, 1, 1.5, and 2. That works for what we've got so far. But now I need to modify this so that anything more than 2, it doesn't output that value, it outputs nothing. I'm going to use a logical statement for this. Which logical statement do you think I'm going to use? Okay, here's what I want you to do. I'm going to ask that question again, and Liam, you just say anything. You ready? Okay, which logical statement is most appropriate in this circumstance? It'd be if. That's correct. So what I'm going to do is I'm going to take that value, I'm going to copy it, and I'm going to write if that thing that we just wrote is greater than 2 for now, output nothing. Otherwise, output that thing. Now when I hit enter, it outputs 0, 0.5, 1, and 1.5, and then 2. However, this only works for this specific circumstance. I need to modify this to make it a little bit more robust. So first of all, I'm going to change this from 2 to what? Exactly, the maximum value. Now it's going to evaluate if that quantity is greater than the maximum value, and if it is, it outputs nothing. So right now, if I change max from 2 to 3, I still have 4 steps, and it switched it to not output if it's greater than 3. Or what about 4? Or 5? Now what happens if I change the number of steps from 4 to something like, oh, I don't know, 8? Or 12? Or 9,005? Okay, so far, changing my maximum value affects my table the way that I want it to. Changing my step count affects my table the way I want it to, the last thing to check is if my minimum value actually works properly. If I change this from 0 to 1, it doesn't work. Oh no. So what do I change about my calculation to make this work? Here, if it helps, we can eliminate the logical statement again. So we're just dealing with this statement. If it's too many things to read at once, I'm taking maximum minus minimum divided by step size. That gives us how far to move with each new step. But I need to add to this value the value of the minimum cell. Right now that's I5. I switch that to an absolute reference by adding the dollar signs. Now I have maximum minus minimum divided by steps in the calculation multiplied by row minus 2 plus the minimum value. Now this will output, why do I keep hitting slash? Now it'll output 1 because we're starting at 1, 1.8, 2.6, 3.4, 4.2, and 5. And if I put this inside of my if statement again, like this, if that thing is greater than the minimum value, output nothing. Nope. The maximum value, output nothing. Otherwise, output the thing. And look at that. It works. Hooray for us. So I change it from 0 to 1. It changes correctly. If I change it from 1 to 2, it changes correctly. If I change the step size, if I change the max, if I change any of these 3 values, these 5 values update. Are you following this? Cool. I will point out, right now we are switching between relative and absolute references pretty quickly. The way that I'm doing that is by using the shortcut F4. So if I type in K5 and I want to switch that to an absolute reference very quickly, instead of adding the dollar signs individually like this, I can just click on it and hit F4. If I hit it once, it makes both of them absolute. If I hit it a second time, it makes only the row number absolute. If I hit it a third time, it makes only the column number absolute. If I hit it a fourth time, it brings us back to full relative. The other thing I want to point out is if you want to make this a little bit easier to read for your user, this is the circumstance where naming cells is super useful. So you know how we're referencing I6 and the user has to go, what is I6? I6 occurs right here. That's the maximum value. If I rename this cell from I6 to something like max, now anytime I reference max, it's going to reference I6. If I change this from I5 to, I don't know, min, now anytime I reference min, it'll grab I5. If I change I7 to steps, now I can go up here and change I6 to max, change I5 to min, change I7 to steps, change I5 to min, change I6 to max, and I have eliminated that additional hurdle for anyone trying to read my code. Okay, I'll give you a second to finish copying that down, if you are so interested in following along. Okay. Next, I need to fix my code because I apparently copied and pasted incorrectly. I didn't have the correct number of parentheses. There we go. Oh, yep, that's great. Ah, there we go. Beautiful. Thank you. Turns out latte, Riemann, and steps are the only 3 words I don't know how to spell. So luckily, we've hit all 3 of them. We're good to go now. Okay. What is the y value for this function with this value of x? What is the y value corresponding to an x value of 3 in this function? I'm not expecting you to do math. I'm expecting you to describe to me how we calculate that. It'd be equals constant a
to the x value
multiplied by x to the fourth plus constant b times x to the third. I will point out that, you know, it would be easier to read than I3, J3, etc. Why don't I just name these as well? Let's name this A. Let's name this B. Let's name this C. Let's name this C. Okay. Can't name it C. C is reserved. Let's try that. C, D, and E. Okay. So now we have cell A, we have cell B, we have cell C, we have cell D, we have cell E. Now up here in my calculation, I can just do equals A times x to the fourth plus B times x to the third plus C times x to the second plus D times x to the first plus E times x. Now I know what you're thinking. You're thinking, but John, we only have a value in the value for C. Why are we putting in all the other stuff? We're putting in all the other stuff because we want to make this able to accommodate any function, any fourth order polynomial. We're building a calculator that solves the problem one time so that we don't have to do this every other time we encounter this exact situation. That's one of the tenets of engineering. Solve the problem once so you don't have to solve it again. Instead of repeating yourself on every single homework problem, you design a calculator that solves that problem for you. Then any permutation of the problem that I can give you, you just solve using the solution you already made. That's why it's so useful to build solutions to your homework problems in MATLAB as opposed to doing them by hand. If you're solving a statics problem and you solve it by hand and you get it right, congratulations, you spent time and effort creating a solution that works for one situation. But if you build it in MATLAB, you could change the input parameters. You could say, what if that beam was 6 inches across instead of 4 inches across? And it will recalculate and give you the answer. You've built the solution one time. You don't need to repeat yourself.
You're saying this is a strategy for next semester.
I'm saying this is a strategy for the rest of your life. NBD. Okay, so I have 27, 42, etc., 60, etc., 82, etc., 108. And then after that it breaks. Why does it break?
You don't have.
Exactly. So I'm going to wrap this inside of an if statement. I'm going to say if x is anything, if it's anything at all other than blank, calculate a number. Otherwise, don't. The way that I evaluate if it is anything is with this, less than, greater than, empty. If it's less than or greater than empty, it is not empty. If it is not empty, return that value. Otherwise, return blank. Boom. I'm going to change min to 3. From 3 to 0, I'm going to change max to 2. Now we are back to where we began. So again, that's if x is not equal to blank, output this calculation for y. Otherwise, don't. Question? Yeah, you're right. I should just have plus e. You are exactly right. Thank you for that catch. Okay. Cool. We are making progress. We have 2 columns done. Now, what about our third column? What is the delta x value for 0 to 0.5? Correct. It'd be the end value minus the beginning value. So the end value is 0.5 minus the beginning value is 0. Difference between them is 0.5. What about delta x for 0.5 to 1? Correct. What about the delta x from 1 to 1.5? It'd be 0.5. What about the x value from 1.5 to 2? You guys are real good at this mental math stuff. Well done. So I want 0.5 to be outputted 4 times because I want 4 rectangles, because I want 4 steps. What that means is I actually want to skip the first row. I want to output nothing here. I want to output 0.5, 0.5, 0.5, 0.5, and then nothing. So what I'm going to do is this. I'm going to say if equals if, and then I'm going to use an AND function to evaluate 2 criteria. If row number is greater than 2, and if my x value is not equal to blank. If both of those are true, output something, otherwise don't. Make sense? So now when I hit enter, I get something in the 4 rows that I want something, and I get don't in the cells that I don't. So if I switch don't to blank, and I switch something to the actual calculation for delta x, I can do this in a number of ways. I could say max minus min divided by steps. That would work. I could say the current x value minus the previous x value. That would work. Why is that now? Oh, because I'm dividing by steps. Yeah. Any way you like. Now if I change this to 8 steps, let's just double check that that still works. Hey, look at that, it still works. Okay. So now I have the base of my 4 rectangles. Now I want to calculate the area using the left-hand Riemann sum for the first rectangle. What is the area of that first rectangle using the left-hand Riemann sum? Keep in mind delta x here is referring to stepping from 0 to 0.5 on the x. Right. I want to take the previous y value, multiplied by delta x. That's going to take 0 times 0.5, and we get 0. Then on the next row, I want to take the previous y value, multiply it by our delta x. Then I want to take the previous y value and multiply it by delta x. And the previous y value and multiply it by delta x. I have 4 values now, each of which represents the area of the rectangle corresponding to the left-hand Riemann sum. So right now, I have broken values in my first row and in every row after the maximum value because there's nothing in delta x. So what would you like to add to this to make it not break? Liam, do you remember your job? You're supposed to say anything.
Why?
Correct. We're going to add in if. We say if delta x is not equal to blank, output the thing, otherwise don't. So now we get b2 times delta x for all of the rows that have a delta x value, and we get nothing for the other rows. Are you following this so far? Okay. What do I change to make this calculation work for the right-hand Riemann sum? Instead of taking the previous y value, I take the current y value. Instead of b2, I take y. So now using the right-hand Riemann sum, that first rectangle has an area of 0.375. Because all the delta x's are the same, I still have 0.375. Does that logic make sense? Okay. Now then, what do I use for the trap? Okay, do you guys know what the trapezoidal method is? I just assumed that you guys covered that in your pre-calc class. Okay.
Long time ago.
A long time ago. Okay. So, just a little bit more context here. If you are completely confused as to what that means. If we break this into 4 rectangles, we are assuming the left-hand Riemann sum starts at where the left side of this block intersects my function. The right-hand Riemann sum uses the height of where the right side of the block intersects the function. The trapezoidal method connects the 2 lines together and creates a trapezoid that has this shape. That is the same area as if it was intersecting the function in the middle. So I don't want to use the previous y value. I don't want to use the next y value. Which y value do I want to use? Okay, I don't want to use the left-hand side. I don't want to use the right-hand side. I want to use the one that's in the middle of the 2. I could subtract them and then figure out the average manually, or I could figure out the average of the previous y value and the current y value by using the average function. So the previous y value, the current y value, close parentheses, we should get an area that is halfway between the left-hand Riemann sum and the right-hand Riemann sum. Does that logic make sense? Okay, so if I sum together my left-hand Riemann sum rectangles, I can calculate the total area under the curve using the left-hand Riemann sum. So I'm going to say equals sum of the entire Riemann LHRS function. Then I can do the same thing for the right-hand Riemann sum, equals sum of the entire right-hand side, and equals the sum using the trap method. Like this. Okay, so the correct value is 8. The left-hand Riemann sum underestimates, and it gets 5.25. The right-hand Riemann sum overestimates, it gets 11.25. Using the trapezoidal method, we get 8.25. If I wanted to be real accurate here, I could say like exact answer. Put in 8, and then have it calculate what the percent error is. How do you calculate percent error? Correct. So I'm going to take the absolute value of exact minus my current value. I'm going to divide by the exact value. My left-hand Riemann sum produces a 34.4% error. Right-hand Riemann sum produces 40.6% error. Trapezoidal method produces 3.1% error. Using our understanding of how calculus works, as the number of steps approaches infinity, these should get closer. And because the trapezoidal method neither underestimates nor overestimates, it should be the closest the whole time. So if we change the number of steps from 4 to 8, we get closer. If we change the number of steps from 8 to 16, we get closer. If we change the number of steps from 16 to 9005, we get effectively the correct answer, regardless of which method we use. And more useful than doing this by hand, we built a worksheet that does it for us, regardless of the circumstance. We can change this from 3x squared to like 3x squared plus 5, and we don't have to change our math at all. Of course, we would have to change the exact value, which would require circumventing the entire purpose of doing this analysis by doing the actual calculus, but, you know, what are we here to do, if not unnecessary extra work to learn things? Make sense? Okie doke. Well, your homework assignment this week is to take this worksheet that we built together. Again, that's going to be available as a video on D2L. So if you missed any aspect of building it together, you can go back and build it together. And then you are using it to evaluate some integrals. That's not what I want. Let's switch from teacher view to student view. That way we can see the actual Dropbox homework assignment. Woo, we did it. So you're taking some functions. You are evaluating an integral. If you use the worksheet we just built, you can do each of these in one spreadsheet, as opposed to trying to do them all manually the hard way. The first two are pretty straightforward. One of them is going to be multiplying a polynomial. The second one is an exponential function for which you will have to modify how we calculated y in order to be able to accommodate that exponential function. The third one I couldn't resist. I wanted to give you a fluids problem. It's not important that you actually understand the fluid mechanics. What's important is that for now, you just take my word for it. You can calculate volumetric flow rate of a fluid, which we represent with Q, by taking the integral of 2 times pi, a constant, multiplied by the velocity of the fluid, multiplied by little r dr. You are integrating from an r value of 0 to an r value of r. I know that seems confusing. We're going from 0 to r, where r is 0.25. Does that logic make sense? Okay. You're taking 2 times pi times this equation, where Vmax is a constant, 1 is a constant, big R is a constant, n is a constant. For now, it's not important that you understand what those mean. And then you're multiplying that by little r dr. If you are wanting to check your math, you can just type that in to Wolfram alpha and have it spit out the result of the integral for you. By the way, if you don't know about Wolfram alpha, you should really look into Wolfram alpha. It'll make all your math classes easier. It'll make all your thermal classes easier. It'll make your fluid mechanics class easier. It'll make heat transfer easier. I'm sure I don't need to tell you about it. That'd be like me telling you about Chegg. You all know about Chegg already. Any questions? Okay. If you're curious, that integral for the fluid mechanics problem is producing what the profile of the velocity through a pipe is, which looks like that. And you are integrating with respect to a radius from an r value of 0 to big R, which is what we call the actual radius of the pipe. So little r is the integrating variable that you're building a bunch of differentials for. Big R is the actual radius. And again, you don't actually need to know that in order to solve the question using the worksheet that we built. If there are no other questions, see you guys next week.